Hello everyone, welcome to AI Anytime channel. In this video, we're going to look at GRPO, Group Relative Policy Optimization, a technique that falls under reinforcement learning. This is the same technique that DeepSeek has used to train their R1 model, right? A technique where people have gone gaga about it on the internet. If you look at fellow YouTubers have created a lot of videos on GRPO already, and I'm not gonna kind of replicate the same. I'm going to keep it very simple. And this video is for beginners. And this is completely going to be ELI 5 video. I'm gonna explain like you are 5 years old. That's how I'm going to explain GRPO. We're gonna code this in NumPy first, a very similar techniques like GRPO for beginners. uh, we're gonna code that in NumPy, pure Python. We're gonna, again take the distilled DeepSeek model and train using GRPO, using TRL library. And now GRPO train is also available within the Hugging Face itself. You can use the GRPO trainer to create the config and train it further. Uh, Unsloth has created bunch of notebooks that you can use to kind of use similar techniques to fine tune or distill other LLMs, using GRPO techniques. So bunch of resources available already. I'm going to make it a bit more simplified for you. So because the reason being because you know not not all that audience that I have, right? They are not reinforcement learning experts. It's an evolving field, very complex, but at the same time intuitive field. So I'm going to keep it very simple. GRPO, right? So novel I'll not say it's a novel architecture, it exists, but DeepSeek has found a way to, use this as a frugal innovation technique to train low cost AI models. So let's jump in and see how we can do that, how we can use GRPO, what does it mean, lemon terms, and blah, 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 right? So if you look at here on my screen, I'm on DeepSeek uh, research paper. It says DeepSeek Maths pushing the limits of mathematical reasoning in open language models, blah blah blah. And it has been GIPO has been the bedrock for this model, right? And we're gonna cover that. I'm going to explain that, but before that, I want to show you GIPO trainer. And if you go on my GitHub repository, I'll give the link in description. I already have kept a couple of notebooks from Unsloth, and but then I'm gonna also keep our notebooks that we are coding. We're gonna code this probably in this video. I'm also already, you know, doing something on the GRP over. You can see it over here. I'm going to give you this notebook, going to explain you and also share this notebook with you, that how you can also use this to train it further. Right now, before that, we're gonna go into understanding GRPO. Right now, I want to explain that as in very simple and plain language. Now, how GRPO is different than other alignment techniques like PPO, for example, which is where these are all based on reward functions and whatnot. So we want to cover a few things in the things. Now, imagine you are teaching a class where students write one short sentence as an essay, right? One short sentence, and you are teaching a class, right? And you do not probably want you want their sentences to follow a characteristic like of a certain style, right? We always prefer if I'm a teacher, I will prefer I will have my own style to teach them, and I will also expect that if they are writing some of my taught topics, they should write probably in the similar fashion or maybe in other fashions. Maybe that's in their style. So imagine if we categorize these into two different groups. One is looking at more vowels where each word starts with a vowel, and the other groups where each word starts with a consonant, right? So and we categorize these two groups and not grading each sentences, but grading the groups. Of course, we're going to grade the sentences, but based on the characteristics that we have defined, right? And we categorize the two groups, and then we find out the relative score with each sentences falls under the group and see how they outperform. And I'm going to explain that so it will be clear. But these are the examples that I'm going to cover. The same can go also on, if you are a chef working and you kind of not you are working on the new recipes rather than individual recipes. You will look at the recipes fall under Asian and the recipe falls under Italian, right? And you then grade them on how they taste. So there will be different examples like this that I'm going to cover, just a very high level overview that I'm giving. So let's go through it. So what I'm going to do is I'm going to bring up my tab here, and we are going to go through it. So let me just explain what I have been saying, and then we're going to code that. We are going to code this in NumPy first, and then I'm going to walk you through all the notebooks that might be uh, you'll be doing. So let's first do that. So what I'm going to do is example one. So I'm just doing example one here. Now in example one, I'll just take this different here. Now teacher collects the uh, sentences and assigning a score, friendly score on 0 to 1, right? And that will be learned weight in reality when you're coding it, but for now we'll keep it simple. So what I'm going to do is I'm going to write an example. So let's first create the group, and the group is nothing but the vowel. So I'm going to write vowel, and you can see it on the screen. So I'm writing group vowel, and the vowel will probably sentences that it starts with. So I'm going to write it here. Sentences starts start with A, E, I, O, U. So let me just write it. This is how the sentence is gonna start, in this particular group. Now I'm going to give some examples, but you can again improvise on top of it. So what we're gonna do is let's take this sentences group vowel. Okay, this is fine. So let's see two sentences. Sentence one. And guys, this is going to be a bit lengthy video, so if you're not interested, you can just skip this. Okay, but if you watch this, it will be very clear for you. So let's write sentence one. I'm gonna write, for example, amazing, work. So I'm writing amazing work makes everyone feel welcome. This is what I'm writing. Everyone feel welcome. And if there is any grammar mistake, please excuse me for that. This is what I'm writing. So if you look at the words, right, sentences start with A, E, I, O, U, and this sentence starts with A here. So if you look at this starts with A. Amazing work makes everyone. And now, for example, if I have sentence two, so let me just write sentence two here. Now in sentence two, I can write excellent, excellent efforts brighten our days. This is what I'm writing. Now let's change the color of it so you can understand this. So I'm gonna recolor this. You can see it starts with A and E, which are vowels, and I'm basically rate them on the first, make them group, and then rate them on the characteristics that I'm defining. So if I have to give a score to this, let's say I give R1, because you're going to cover some mathematical intuition behind it. So R1, and if I just rate it, now this rate that you see will be the learned weights when you are training a model, but I just hypothetically, I'm just giving it a number 0.90. Now 0.90 and 0.95 based on the scale from 0 to 1. Excuse me, guy, I have a bit sore throat, so please adjust with that. Now this is fine. So I'm gonna just again go on the group. So let's go to group 2. So on group 2, excuse me. Okay. Now on group 2, which is nothing but the consonant. The group 2 is going to be consonant where it starts with other letters except vowel, right? It will be not A, E, I, O, U, but anything except vowels. This is what I'm going to define, and let's just take something here. So sentence 1 and sentence, let's write sentence 1 and sentence 2. Okay, perfect. Sentence 1 and sentence 2. Now, excuse me, I'll just, okay, that is fine. Sentence 1. Now let's write here. From what I'm writing is, let's write, you can see I'm writing brilliant ideas. Write anything like that's fine. I'm writing creativity. If you look at here, which starts with B, which is of course not a vowel, which is a consonant. And here I'm going to write the next thing, which is anything. Caring heart, build, build strong communities. So this is what I'm writing, and this becomes your caring. So let's give a score. So what I'm going to give is here R3, and R3 can be 0.85, and R4 can be 0.80. Now I've assigned these scores over here, you can see, and you can have one more sentences if you want. Okay, so for example, let's say, because both will be same, so that might create a bit confusion. So let's have one more extra sentence here. So I'm going to keep one more sentence, and let's write determine student. I'm going to write determine students overcome challenges or something. I don't know if this is grammatically correct, but yeah, this also becomes a sentence that starts with a consonant, not a vowel. And if you assign R5, you can give it a score 0.75. Now, these are the score we have given. Now, if you compute the group averages, right? Let's compute the group average. So I'm computing the group averages. So if you compute the group averages over here for the vowel group, so I'm writing vowel group average. So what will be the vowel group average? If you look at the number here, we have 0.95 and 0.90. So what I'm going to do is I'm going to call it R1 plus R2 by 2, and this becomes 0.95 plus 0.90 by 2, and this becomes 0.925. That's what it becomes, right? This becomes my group average. And similarly, if you go to consonant group average, so let's go to consonant group average. So for consonant group average also it will be R1 plus, not R1, R3 plus R4 plus R5 by 3. And if you do that, it basically comes up with all the scores that we 0.858075. So let's first write it. So 0.8580 and 75. So 8, 8, 16, 7, 30, 30, 32, 35, 5, 5, 4, 0.80. It should be 0.80. Now this comes 0.80 and this comes 0.925. Now what are we going to define? So if you compute the, now as we have this, we want to come up with the relative score. Right now we have to look at the group relative advantage for each sentence. Right now we are not looking at the each sentence. So if you look at the each sentence, let's probably look at that now, which is important. So for each sentences, what I'm going to do is I'm going to define a formula here. Let's say AI and then call it relative. And AI relative is nothing but R minus R group, and that's going to be relative. So that's how I'm going to define it. This is going to be my formula, and very similar. If you even if you are reading the research paper, you'll come across this kind of mathematical formula. I'm keeping it very simple. Now, this RG that you see is nothing but the average score of the group. And this Ri is the individual score. So R1, R1, R2, R3, R4, R5, and then whatever score comes in. So if you look at for sentence one, let's only look at for sentence one here. So I'm gonna write A1 relative. The how much was that? It was 0.95. So if you come 0.95 minus 0.925, this comes 0.025, which gives us a positive score. If you look at A2 relative, it was 0.90 minus 0.925, and you know it becomes minus 0.25, right? Now this is where it comes, and you can go for the consonant as well. If you look at the sentence one, now this sentence one has a higher score in comparison to the group that we have, which the group by 0 plus 0.025. So this gives you plus 0.025. If you go to the consonant as well, let's look at the consonant. If you look at this is 0.85. So if you come down, Yeah, this is 0.8. So that will also give you plus 0.05. So R1 and R3. So I'm going to write R1 and R3. These two score gives you positive relative advantage. And that is how it means they are slightly better aligned, than the other scores, individual scores that you see for this particular condition or the characteristic, whatever you call it, you know, uh, with the friendly style that teacher has set or they want, right? And that's how you align the model when you go with the GRPO thing. And similar way, you can look at any other example, you can define it, right? So this is the core idea behind GRPO, like how we learn and update based on the relative performance within the natural groups that we have. This is how simply you can explain that. Of course, you can go and look at the more mathematical intuition behind it, like how we use the how we take the advantage, for the updates, and how do we compute, blah blah blah. So it basically says assign, calculate, group, and then update. These are the four. Now let's go and look at how we can code this. So what I'm going to do is, of course, I'm going to give this probably this snippet. You can also take it. Now let's see how we can code it. So I'm going to do is import numpy as np. And this is not going to be your language model training. Here we're going to talk about how we can, look at the concept that we have mathematically defined on the groupism grouping thing, and how do we align it better. And then we'll go into the available notebooks that we already have and the trainer class, blah blah blah. I'm already fine tuning it. So if you look at here on my screen, we're already fine tuning here. So we'll cover that. But let me first explain you this. Now let's create a simple vocabulary. So I'm going to create a simple vocab here, and I'm going to call it vocab. So vocab equals, yeah, this works for me. So I'm going to not, let's add more apple, what we can do. We can add cherry, apple, cherry, mango, banana, dates. We can keep dates. This is fine. Okay, and this makes sense. And then just run this vocabulary, vocab. I hope we have good. Now I'm going to randomly get we're gonna use we're gonna randomize this, but in the real world, as I said, right, this will be the learned weights. It has to learn from the when you are training the model. But just to uh, go through it, I'm gonna create. So let's first do np.random.seed, and then I'm going to get the logit. Now this logit has to be the learned weights, but here I'm just gonna randomize this, shuffle it. So not shuffle, random.rand random built-in function, and then get the length of vocabulary length, and then it should show vocab. Yes, this is the right. Now let's get the logits. You can see it basically gives you a numerical representations, of that vocab. Now we're gonna write a simple softmax function. So let's do softmax here, and then pass x here as softmax function. Exponential, yeah, not that. Let's define a variable x, and then I'm going to have np.random, yes, and then not random, np.exponential. What's the formula of shortness? np.exponent. And here you pass x minus. Yeah, this makes sense. Okay, now this is what I need, but probably we can define that. Yeah, this is fine, np.sum. See, sometimes it does not give you the recommended thing. When you remove it, then it gives you. So here, this is a softmax function. We have softmax. Now we're going to sample a word index from the probability distribution that defined by this logit. That's what we're going to do. So let's write that function. So I'm going to have a sample word here. So define sample word, and then pass all the logits, and logits are coming from here. This makes sense. And yeah, this makes sense. Okay, so let's return not that. Okay, we're going to return the word index and the props. So let's return the word index and the probabilities. So let's do the props. This is what you're gonna return. Sample word, this is fine. Softmax logits, word index np.random.choice, length vocab. Yeah, this makes sense. Now once that is defined, what we're gonna do is we're gonna define a reward function, and that's where it comes your, because right now I'm gonna write a very simple reward function, but then you're gonna use maybe depends, right? You can need a different data sets, a different model, to use a reward function and whatnot, right? So here I'm gonna keep it very simple. So reward, define reward, and then I'm gonna write word index, and here we have that reward. So let's suppose our alignment target is the word starting with the vowel, because remember we started with the vowel thing. So for example, if you look at this particular, here we have apple, A as the vowel. Yeah, we only have one as vowel, right? So for example, if we should have kept it more, man, but that is fine. We should have kept it like, what can we remove? Let's remove mango. So this is good. It has only one uh, reward, one word which starts with the vowel. I'm gonna run this again. Now here the idea is, as I said, right? Suppose the alignment target is a word start with the vowel. So for example, that will return one for the word starting with a vowel, else zero, right? That's what we're gonna reward. So here let's have a word, very simple. Okay, so word. Let me just write it, guys, here for you. So here I'm gonna write for demo, our alignment target is word start with a vowel and return one for uh, word start with a vowel, else zero. Yeah, so I just wrote it. Now here in this function, let's have word, and then you write vocab, and then pass the index of that. So word index, that's what we're gonna pass. So word index, yeah, this should work. And then I don't know why it's not suggesting me return zero if word lower in AIO. Yeah, this is fine. Okay. Very simple. We're not training any model over here, but yeah, this define. Now let's we have to assign a group based on the target, based on the word basically. That's our target. And group, like we're gonna group vowel for word starting with the vowel, else consonant, right? So let's do that. So I'm gonna have a group label. So group label over here, and within this group label, I'm gonna pass the word index, and then I'm going to pass, yeah, this makes sense. And else not two, like return one, and this is fine. You can also map that if you want, but I'm gonna keep it vowel if word lower in A E I O U, else consonant. Because that's the example I gave you, so I'm just writing it. But you can create different examples over here. So what we are doing, word vocab index, vocab and the word index, and then return vowel if word, the word and in the lower in A E I O U, and else consonant. That's what we are doing. So let's run it. Now define the hyperparameter here. So I'm going to just write hyperparams. Now within the hyperparameter, let's have number of iterations, and let's keep it some whatever, for now. Okay, number of episodes, and like how many samples per iteration. That's what episode means. So number of episodes, and then I'm gonna keep it 20, and then you keep it learning rate. Let's keep it learning rate equals, let's like for example 0.1. This is fine. This is my simple hyperparameters. Now here I'm gonna write bunch of code here. So let's do for iteration. For iteration in range, no, this does not make sense. Iteration in range, num iterations, and then probably you're gonna plus that with 1. I don't know why it does not show me. Okay. So here you're gonna collect a batch of episodes. Like each is a one-step episode. So what I'm gonna do is, how do you wanna write it? For iteration in range, one iterations plus 1, and we need a trajectories. So trajectories, like each entry, basically it will have word index, it will have reward and the probability. a group and the probability. So in trajectories, it's a list that we're gonna append it later. So trajectories, and then for uh, see, and I thought Copilot would have been so good. Okay, this makes sense. Uh, but I'm just gonna have the num because we also have to take the probability. Yeah, this is making sense. So now this makes sense. So for word index, prop, sample word, logits, and then here I'm gonna have R, which is nothing but the reward. So I'm gonna use the reward function, and in reward I'm gonna pass word index. Okay, this makes sense. Reward word index, and then I'm gonna append my trajectories that we have on top. So trajectories dot append, and we're gonna append that with word index, the reward and the group and the probability. So what we're gonna do is yeah, let's just write whatever we have. Word index, so I'm gonna have word idx, and I'm gonna have R, and I'm gonna have group, and then I'm gonna have probabilities. That's what we're gonna have. And I missed the group. Okay, so here we're gonna have group. So group equals I'm gonna group label, and that's fine. And then we pass the group, and then we pass the props. Right, this is what we're gonna do. Append, and this has to be append list. So this has to be this. Okay, now this should append it. It's collect like this will help us collect the batch of episode. So we are okay. And now we're gonna go into group reward. So let's define a variable group rewards, and we're gonna compute the average reward within each group. So this group rewards has to be a dictionary. So group rewards, and then the group counts, and this also has to be now for words index n, for word index group. Yes, trajectories. If no, this does not make sense to me. So for word index and we want to have group rewards. So let me just do group rewards. Yes, this makes sense. So group rewards dot set default group, and then it will be 0, and then it will be group count dot set default to be 0, and then group rewards group plus equals R. Yeah, this makes, now this is fine. Now we're gonna avoid division by 0. If a group did not appear, we can set its average to 0. So for that, for group, no, we're gonna get the group average. So group, okay, we don't have it. Group average, let's just group average, and then we're gonna write group and group rewards that we have on top. Excuse me, group rewards, and then I'm gonna pass the group here and divide that with group counts. Yes, this is fine. GRP for group in group rewards, but this is not making sense. So I'll just get rid of this. This makes sense though, but here we're gonna have group rewards. This is fine. Group rewards if group counts. What does it suggest? Perfect. This makes sense. Okay. Now for word, this is not required. Okay. Now let's get rid of this. So group average. Okay, this is fine. Now let's get the gradient. We're gonna compute the gradient using group relative advantage. We're gonna have np dot zeros. Yes. Zeros like, do they have it? Yes. And then give the logits, and then get the total advantage. Total advantage for grouping. No, not for grouping, for reporting. And total advantage, and then for word index, for word index group and props in trajectories, advantage, R minus group average dot get, not required because we already have that group over here. So we can just write group, and let's keep it advanced. R minus group average. This become front. Let me see. Advantage equals R minus group average, and then we pass this particular group. And then total advantage plus equals advantage, and then oh, it has here. We don't need that. Total advantage equals total advantage plus advantage. So this makes sense. This is fine. So now the gradient of the loss probability for a softmax is gonna calculate that. So what I'm gonna do is get the grad sample. Excuse me. And in grad sample, I'm gonna have props dot copy. So it starts with minus p for all indices, right? So this makes sense. And then I'm gonna have grad sample word index, word index, and then I'm gonna probably you can also do plus or you can also do it later for taken, and then I'm gonna have grad sample into ADV, and now we get the logits, learning rate, and into gradient. Now just gonna report these iterations and we'll be good, right? So let's just write reporting for this iteration. Okay, and we were reporting for these iterations, average advantage. So let me just do average advantage here, and this becomes total advantage. This is fine, and then we print iterations and average. Yeah, this is fine. Average advantage, and then you have we're gonna need the updated probabilities. So let's get that. So print updated probabilities, and then updated probabilities. And how do we get that? For word P in zip, we're gonna zip the vocab and props, and then just print that. We're gonna print words. So sad. Okay. We're gonna have words, not words, it word, and then prob, and you need up to few decimal points, floating points, whatever, and then we just print the average group, print the average advantage. Probably I'll just get rid of this here and just keep it iterations. That is fine. An iteration up to decimal point. So this will make sense. Iteration, and then I'll just do this. Okay. Now here I'm gonna print the here I'm gonna print the average group relative advantage, and then you just write average advantage 3. Yeah, this makes sense. I'll just get rid of this, or I can also just get the next line here. Okay, and then this is fine. And now you can see it. So let's go through it. So if you look at here, right? Fantastic. We grouped them, we calculated, we did a lot of things here, guys. If you look at here, let's go on top. Iteration 1. So if you first go on top, and we are doing this in completely Python, NumPy, guys. No libraries and stuff here like transformers or whatever. Now, so if you look at here, number of iterations 50. So if you come here, apple, updated probabilities, and elderberry, and yeah, so this will go up to 50 iterations. So you can come down and you're going to find it out. Okay, up to 50 iterations. Fantastic. Now this is fine. So let's just look at the final observation. You will just get the same thing here. So print and final vocab, final vocab probabilities after GRPO updates, and you can just get this. Okay. Forward P in zip, and then you just pass the vocab, and you have to use softmax to pass the logits. This should make sense. Okay. Let's see. This makes sense. Yeah, this should be fine. Yeah. Okay, I have made a typo here. This should be vocab. The final vocab probabilities after GRPO updates. Apple and elderberry. You can see it over here, which are more aligned, for the given condition where we were looking at the vowels, the word which starts with it. You'll see it over here. Now, this is a simple way we coded it, okay, in Python. Now, you'll be interested in to take any model and then align that, or that use GRPO in the language model. So what you can see it here is that TRL supports the GRPO trainer now, for training language models. You can find it out here. The GRPO trainer is now available. But before that, I'm going to show you Unsloth GRPO. So if you write it, Unsloth here. Now, if you go here, they have 3 notebooks. It says Reasoning GRPO RLPPO, Proximal Policy Optimization, a technique before GRPO, everybody was using it. But you can, if you go to these notebooks, you can find it out. If you want to use Llama 3.1, 5, 4, or QN 2.5, you can go through this entire notebook. And the good thing is that it also works on the T4, so you can use FreeCollab to basically, work with the GRPO over here. Very similar thing, guys. And if you go through it, you will find out what I'm saying. But they have, you do not have to look at the source code because they already have created GRPO config and GRPO trainer, which is available in TRL. You can see it over here, and you can just use the reward functions and whatever which is already there. You do not have to do it. Okay. So the notebooks are available, but what I'm doing here, I'll show you. Okay, let me just go on top. I have this thing that I was referring it. We have TRL that you see. If you don't know, it's a transformer reinforcement learning library that's called TRL. Uh, that's the acronym for it. We have Levenstein, which is for string similarity, because I will tell you the use case over here. And then we have bits and bytes for quantization. Now, what we're going to do here is to fine tune the DeepSeek R1, distilled QN 1.5 model with the GRPO training to improve its ability to solve mathematical problems. That's basically the use case. So if you come down here, this is fine. This is for just looking at the CUDA kernels. We have all the imports over here. Now here we have a configuration. You see this class where we have max training, max tokens, number of generations, huge PIF, parameter efficient fine tuning. Like, do we need PIF to fine tune this? Then we're gonna, by default we have yes, because true, because we want to run this on compute limited device on a single GPU to fine tune this model, where you do not have an a luxury to do full fine tuning. So you need PIFT kind of technique to use LoRa adapters or whatever to LoRa to kind of do it, and then merge the adapters later to get a model. So that's the idea. We have maximum steps, batch size, learning rates, blah, blah, blah. I've downloaded this model from here. You can see it over here. We have this model data coming from this. You can just skip this, some of the functions. This is the data that we are using, math problems. This is the data that we are using from Kaggle. This has math problems. If you go to this here, let me just copy this, come over here. I'm going to do paste. Now this is the math problem. If you look at here, it says 100,000 diverse problems for International Math Olympiads. Now, if you want to take the distilled DeepSeek model, distilled QN 1.5, and use GRPO trainer to improve the ability so it can perform better on these kind of math problems. That's what we are doing here, right? Now, if you look at here, now we just read it, we get all the data. You can see we're looking at only the first few samples, the rows, whatever you call it. We use the tokenizer to tokenize it, create prompts. You can, if you look at this prompt here, now here in prompt we say conversation between users and assistant, blah blah blah, return final answer after the whatever. Okay, and then we have bunch of things that I probably more interested. These are nothing but the reward function. If you look at this format reward function, this evaluates whether the generated text follows a specific format. That's what we are doing. Remember that time. If you look at the example that I explained, vowel, consonant, if the word starts with a letter, whatever, right? So same thing. Here we look at that. If you see this, it says regex.match pattern content dot all for content incompletions, return one if match, else zero for match. Simple thing, guys, right? It's not that complex. You have to understand and then code yourself and then look at the resources available and train a model, right? How intuitive it is in that way. Now, this function, accuracy reward function. Now, in this accuracy reward function, it basically evaluates the accuracy of the generated answer, and if it matches the correct answer, rewarded with 1. If you look at here, it's rewarded with 1 if correct, else 0 for otherwise, like whatever, if it's not correct. Now, this Levenstein reward function is very interesting. What it does is evaluates the quality of the generated solution based on the Levenstein distance. So if you have worked with the vector similarities, you are working with a lot of RAGs nowadays, right? People have been working with retrieval augmented generation where they look at the vector databases and how they're creating RAG chatbots. It's all based on cosines, Levensteins, Jaccard, blah, blah, blah. So this is how it works. This is what it's doing. Now, here what we do, here we load the models. If you look at here, we are loading the model, the DeepSeek R1 model. It depends on whether you use PIFT or not. So very simple. Here I am using cfg.use_pift. And if you are using PIFT, then it's fine. Otherwise, original model will be loaded like this. Make sure that you use PIFT. Right, this is what it's doing. Now here we are applying the prompts to a data set. So just map using the map function to use the create prompt. If you go on top, here we have a create prompt function. Now this is where you guys have asked in the previous video to create this kind of fine-tuning video on to apply the prompt templates or the structure, right, of the prompting. So that's what we are doing over here to generate the prompt. Basically the function to the data set and generate the prompt. Now, this one is an evaluate the performance of the model, evaluate rewards, if you see here, and evaluate it with the pre-trained model. That's what we are doing. So I'll just go up. You can see the accuracy, 0.5, solution quality, blah, blah, blah. Now, this is fine. Here, if you go up, here we are setting the GRPO trainer. So this is the GRPO config, very simple, similar to other configs that we have used in past. But here we have GRPO config, you have trainer config earlier, if you have used SFT, supervised fine tuning, blah, 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 and whatever. Okay. Here, very simple, we just write it. Okay. Stuff. Here are our PIFT setting. If you are using the PIFT, so these are the rank, these are the LoRa alpha. Higher the rank, higher the compute power, guys. So 32, you can go 64 as well. We have, target modules in the attention layers, Q projections, vproj, whatever, blah, blah, blah. Causal LM, we are looking at it supports causal LM, does not support masked language modeling. So causal LM for generating text. PIFT configure LoRa here, guys. We are configuring the LoRa over here. If you look at this one, and this is where I'm training right now. So if you see this, it's gonna take some time. So this will be available for you to take it. Now this is going to take time. This is fine. Loading train models, blah blah blah. And this is basically load and evaluate a train model. That's what it does. So rewards will basically print, and I will share the result. And you can also run it. I'm running on an A100 GPU, but this is going to take a lot of time, guys. It will take 1 more hour, I believe, or so. You can see I'm running it for the last 1.5 hours, and now it's going to take 1 more hour. So it's going to take time. So this is how you can train, and we'll see the comparisons on how if it's able to improve the performance on mathematical problems that we have over here, International Mathematical Olympiad over here, and that's what it is, guys. It's around 74 MB, right, by this guy, which is fantastic. Now, fantastic resources available, guys. You can also go through these notebooks. I recommend you go and check these notebooks by Unsloth as well, or you can go through these notebook, and you can also go through this basics one. Sorry for coding this a bit over here, like just like I would have copied pasted as well from GitHub or something, just, but that is fine. Very similar, right? Intuitive. The way here we did with the vowels and consonant, the same thing. If you look at here, I explained that over here. If you come down here, over here, similar stuff, right? And then you just follow it. So I hope you got an idea of GRPO. I don't want to create a only saying that DeepSeek has used it. Like everybody knows that DeepSeek has used GRPO, but what next? How can you do anything with that? That's the thing, and I want you to invest your time to do hands-on and practical sessions rather than just looking at videos where people are just talking about, that DeepSeek has used it. DeepSeek has used it, but what about you? Is the question. So you can go and distill this kind of model, use this technique on different problems. So, for example, if you look at here, we are looking at the mathematical Olympiad problem, but you can go through other problems, data sets, healthcare, marketing. Yeah, you can go to a lot of other industries to solve problems, with this and train a low cost AI model. This resources will be available on my GitHub repository. I'll give the link in description. And if you have any questions, thoughts, or feedbacks, do let me know in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. If you have any question, thoughts, or feedbacks, you can also reach out to me through Discord. So you can join our Discord community, guys. I'll give the link of Discord community in the description. And if you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. I hope you understood a little bit on GRPO complex topics, guys. Don't believe in people when they say it's not complex. It's really evolving complex. You need mathematical understanding to go through it and then start doing something on top of it. So I hope you've got a little bit of idea and you can now take it on yourself and start building on top of it. That's all for this video, guys. Thank you so much for watching. See you in the next one.